Imagine waking up in the morning only to find that everything is covered in snow. Snowflakes have that complex science behind its beautiful six-sided design. Let's dive into the wonderful science behind snow, why it's a hexagon, the different types of snowflakes, and the photographer who took the first photomicrograph of a single ice crystal. So why is a snowflake a hexagon? We know that snow is water, which is H2O, but what does this mean? According to Matthew R. Francis, author of Why Are Snowflakes Always Six-Sided, it's because of hydrogen bonding. But in order to understand what hydrogen bonding is, we're going to need to study the anatomical structure of a water molecule. Oxygen atoms have 8 electrons total, 2 on the inside shell and 6 on the outside shell. But the outside shell can hold up to 8 electrons, so there are 2 extra spaces. Those 2 extra spaces are taken up by the hydrogen atom's 1 electron. Together, the atoms share electrons. But the oxygen atom is somewhat grabby, and it pulls its shared electrons a little bit further away from the hydrogen atom, making it slightly more negatively charged than the hydrogen atom. The other 4 of the oxygen's electrons on the outer layer pair up and chill out on the opposite side. When a water molecule bonds with another water molecule, the negatively charged pairs on the oxygen atom bonds with the positively charged hydrogen atom. Each water molecule attaches to 4 other water molecules, making the tetrahedral arrangement. Those bonds are what determine the shape of the ice crystal. Once water freezes, those tetrahedral arrangements come closer together into a six-sided shape. However, water starts to expand a little bit between 4 to 0 degrees Celsius, and the bonds begin to stretch until they're the furthest distance from each other. This is seen as the hexagon growing larger into a six-sided snowflake. Although there are at least 35 different distinct types of snowflakes, NASA categorizes them into 8 main categories: stellar dendrites, sectored plates, hollow columns, needles, spatial dendrites, capped columns, rime crystals, and irregulars. Stellar dendrites, perhaps the largest type of snowflake on Earth, are singular crystals of ice that have 6 symmetrical branches and randomly placed side branches. They can grow up to be 5 millimeters or more across. Sectored plates have distinctive prominent ridges that make plates. Hollow columns look like a wooden pencil and often have conical hollow ends that are symmetrical. They are so small that you need a good magnifier to see them well. Needles are hollow columns that grow so long and so thin that it's essentially a needle of ice. What's interesting about needles is that when the temperature changes by just a few degrees, a crystal growing into a flat snowflake can change to a long, slender growth. Spatial dendrites are made of many ice crystals that are jumbled up and have randomly orientated stellar branches. Capped columns started out as a column but were blown to an area with a different temperature and switched to a plate-like growth. Rime crystals are covered in rime, which are water droplets frozen on to the ice crystal. Finally, there are irregulars, the unfortunate snowflakes that fall to the ground broken, ill-formed, or just in bad shape. These 8 categories are what NASA uses to classify snowflakes. Scientists and photographers were amazed by snowflakes and spent time studying them to teach others. The most well-known photographer is Wilson Snowflake Bentley. Bentley was born February 9, 1865, in a small town called Jericho. According to Duncan Blanchard, author of The Snowflake Man, Snowflake Bentley was about 15 when he became absorbed to studying water in all kinds of forms, especially as snowflakes, because of his mom's small microscope at home and because of the long, hard winters common to Jericho. Instead of playing outside like the other boys, Bentley would be peering into the microscope, studying all sorts of microscopic things. For 2 years, he attempted to sketch the snowflakes he found under the microscope, but found that they were a poor resemblance to the actual thing. Soon, Bentley discovered a camera that could take pictures through the microscope. He and his mother managed to convince his father to buy it. To his father, the whole project was nonsense. Snowflake Bentley experimented with the camera and dried plates to record the photographic images. Failure after failure, he slowly approached his goal, until finally, on January 15th, 1885, he took the first photomicrograph of a single snow crystal. For years, he worked quietly, taking photograph after photograph of snowflakes, questioning why the flakes vary from one storm to the next. But he was quiet and didn't say much about his work, due to the fact that he didn't get much education. One day, he was found by Professor George Perkins. Professor Perkins saw Bentley's discoveries as outstanding and convinced Bentley to share his discoveries to the world. Today was quite the snow day. First, as the water droplet was falling, we learned how it freezes into a beautiful six-sided snowflake. Next, we classified that crystal into one of the 8 main categories used by NASA. And finally, the snowflake fell into the mittens and under the camera of Snowflake Bentley, the photographer who is best known for his pictures of intricate snowflakes.